But if you want to just hit the next button.
Yeah.
And then you're ready to go.
No problem. Thank you.
Yeah.
Sorry.
What do they say? March goes out like a lion and April comes in like a lamb, something like that.
Yep.
All right. Welcome in today, Friday. Everyone's probably looking forward to the weekend. So the code topic of the week is don't overpromise or under-deliver. Ben? Oh, I can hear Ben. Can you hear him?
Did not. I see his lips moving.
How about that?
There we go.
That's
Is it working now?
Yep.
It said Matt Orzalak muted me. I don't know. Be accurate and be dependable. Strive to be accurate and dependable. That's another way of saying that one.
All right. We've had 9 days without a recordable and 9 days without a first aid, so we had a good week this week. Keep it up. I want to talk about human factors in safety today. Complacency, distractions, exhaustion, overconfidence, and arrogance are the 4 main factors when looking at this. So complacency. Sorry. It's a common thing you might hear is we've always done it this way, and nothing has ever happened. It only takes one time for something to go wrong, so you want to take corrective actions. Don't just ignore something because there's never been an issue with it. You know, don't be like, oh, I don't need my hard hat. I'm only out there for 5 minutes. So make sure you have those things on. You take the precautions. Another example, would be, you ask why were you on that roof without fall protection? And the answer would be, sorry, I didn't even think about it. I just ran up to grab my tools. Distractions. You want to keep your head in the game. So you may have had a argument with your spouse or your loved one that morning, and that's all you can think about, or you receive some spiteful comments from your boss, and it's just consuming your thoughts. Your head's just not on the work. And that goes both ways also. So if you're a supervisor, foreman, you got to think about what you say to your guys. You may say something that seems inconsequential to you, but that's all they can think about all day. You may have weekend plans that are coming up. You may be looking forward to that fishing trip with the guys that you've had planned for a week. So that's all you can think about. And cell phones. Everyone's guilty of being on their phone, and some people like to wander around and walk when they're on the phone, and they don't even notice it, and they don't notice their surroundings. Try to keep focused on on your task. It's pretty much impossible to multitask. Exhaustion, hungover. Avoid excessive indulgences before the workday. Know what you have to do the next day, and make sure you're getting enough sleep. You may have a long work day ahead of you. You may have a long commute. You get home, you eat and go to bed. And if you're tired, make sure you're taking breaks. If you're doing something monotonous, repetitive, make sure you're taking breaks and getting your mind thinking about something else once in a while. Overconfidence, arrogance has a lot of overlap with complacency, but this is more of like, a conscious, I don't need to do this. I've done things like this 100 times, like, working on equipment without turning it off or locking it out. You know, I've done this hundreds of times. Nothing's gonna happen. You get so good at a dangerous task that you no longer feels unsafe for you to. You kind of get numb to the hazards. So this is one way we look at safety, look at incidents and all of that. You look at this pyramid and you work from the bottom up. You want to cut down on the unsafe acts, the unsafe behaviors and conditions. You know, we want to focus on eliminating unsafe behaviors, because the more we have unsafe behaviors, it works up that pyramid. We'll have near misses, minor injuries, or a serious injury, death. So we want to report everything, you know, even if it seems minor, so we can look at it and figure out, you know, what we're doing wrong, what we need to change. We want to be proactive in our choices, so we want to investigate those near misses. We want to solve the issue before it's something we have to, you know, look at and make a knee-jerk reaction because we had a serious injury or death. Yeah, we try to give you all the tools to be safe and all that, but you need to make sure that you're the right mindset to do the work and stay focused. That's all I got for you.
Oh, thanks, Austin.
Thank you.
I'm gonna switch over to my screen to start with here. Share. There, do you see my screen?
Got it.
Good, okay. Switch it out. All right, so get started on announcements here. Try to scroll down. There we go. Couple from the last few weeks was vehicle insurance cards are in. See Chico, Pat Wells, Scott Burns. If you have a vehicle assigned to you, please submit your maple sugaring photos. I'll probably do it next week. We're just trying to gather up a few more. And then a couple announcements that didn't make it on. I see that Melanie told me or sent me an email that we have Morgan Stanley coming on the 5th of April, so the first Friday in April. So there's slots available for consulting from those guys for your 401k. And also just a sad note, I haven't got any information other than that it happened, is that George Shortsleeves passed away in the last couple days. So we'll get more on that for next time. And the good news here with Ken Allard, PE, our newest registered professional engineer. So we're really excited and happy for Ken. He passed his recently took and passed the 8-hour-long Principles and Practice of Engineering exam. The criteria for the exam includes graduation from an accredited engineering college, successfully passing a 6-year fundamental of engineer FE exam, that's back when you graduate or near the time you graduate, and then a minimum of 4 years of responsible engineering experience. And Ken joins the other ECIPs. We have Ben McKinney, Ben Heath, Cody Marsh, Mark Pelkin, and myself. So we're pretty excited to have another PE.
Awesome.
Last call. Today, I'd say sometime next week, Sarah will be placing the order for the ECI children's size sweatshirts. So we'll get an order going here. And I have a link to the primary care wellness program. So also this week, we're going to talk about the Genesee and Wyoming 2023 Northern Regional Capital Bridge Project up at the East Alberg Trestle between Swanton and East Alberg. And I see that Ron and Ben McKinney are on. Are you guys going to present? Do you want to take over the screen or anything, or do you want me to scroll?
Yeah, I'll share. Let's see.
Okay, go ahead. And you can finish up the photo archive too. Just carry on to finish that up. So there's no transition back to my computer.
Cool. How's that look? Can you see that?
I have to get back
Yes,
to my screen.
we can.
Yes, I see it.
Great. Ron's gonna chime in if I start telling lies. So ECI is contracted with Genesee and Wyoming, parent company of the New England Central, to perform various structural repairs to the East Alberg Trestle. Built in 1911, this wooden bridge is approximately 3,500 feet in length and crosses Lake Champlain just south of Missisquoi Bay. I think that's the first lie. I think it's more like 3,700. 3817 it says here. Here's a original plan from the original construction, and you can see some markups for ideas somebody must have had over the years. Like they've got all these wooden cribs and piers that don't actually exist. But kind of
It
a
would have
neat,
been a good idea, right? We'll talk about, or you'll talk about that.
yeah, but you can see how long the bridge is here. Crazy. Most days the bridge sees two trains. CN comes down and drops cars or picks up cars in St. Albans and then heads right back north into Canada. So you can see that the trestle here, we got a couple crews out there on that day. This is a picture taken from the highway bridge, the 10-year-old or so Missisquoi Bay Bridge. Trestle is made up of hundreds of bents, frames comprised of 6 timber friction piles driven into the muck with 14 to 16-inch timber cat beams on top. So you can see some typical trestle construction with these fender piles, the outer two on each side of which are battered. And that print that we showed before shows the original pile lengths, which ranges from 40 feet to 65 feet. But I think there's that plan shows some inferred rock, but I think these are primarily friction piles driven into the muck, not end bearing. Some bents, especially on the north, have additional fender piles outside the 6, which provide an additional degree of lateral bracing and some protection from the ice. The main protection from the ice now is a water bubbler that's been there for longer than I've been around, which is just a simple, pipe with a bunch of holes in it that makes bubbles so ice doesn't form. So it's simple, but effective as long as the air stays moving. So more on the typical construction, you've got your 6 piles, a cap, and 6 18-inch deep stringers that span about 13 feet from bent to bent. And then of course those stringers are spanned by the bridge ties. That's not a stringer you see here in the picture. That's a different piece of wood that's really. Ron, what is that pipe there? That's not a water bubbler header, is it?
That's all part of that's like the main supply to the bubblers, and there's drops that go down from that to actually feed the bubbler that's in the lake.
Got it. And they take that out every year, do they?
Nope, that all stays in there.
Okay. Cool. So navigation is permitted through this bridge by a movable swing span near the center. So you've got this big timber bridge, and then you've got a couple, cribs or islands with piles and wood lagging and stone fill. One at the center of this 2-span movable bridge, which is at the pivot point, a center bearing, so it can move. And then the other on, behind me in this picture, which has got a lot of other things on it. It's pretty neat. We automated this about, 13 years ago. This used to be manually swung. So between extracting the wedge bearings and turning the bridge, that was all done with a super deep capstan style wrench and deep gear reduction with 2 different gearboxes and linkage. And we did a ton of work that we won't get into here to make that controlled by ARDC in St. Albans. So the bridge can be opened for boats and then closed for trains in the summer months. If you want to learn more about that, there was a link to the original article and a YouTube video in the email. Being a very old and long wooden bridge subject to high train loading and all types of weather, the NECR is forced to spend hundreds of thousands of dollars each year in maintenance. ECI over the years has performed much of this, or maybe even the majority of this. Typical maintenance includes replacement of caps, stringers, bridge ties, and yeah. And when individuals piles rots out, we have to replace those too. That could be done by pile posting, cutting the original pile below the rot line and replacing just that pile. But typically we'll do a whole bent and what's called reframing a bent, or doing a bent cut down, where we'll cut all the piles down in a bent, put in a sill, new piles above it, typically a new cap at that point. Of course, then instead of having this big cantilever stiff pile that's got some lateral and longitudinal resistance to load, now all of a sudden you have a hinge, right? Because you've cut it off below the rot. And so when we do that, we are also required to put lateral and longitudinal bracing to stiffen that up. So our current contract is includes 10 of those cut downs, 10 of those full big cut downs, which are quite a bit of work. You're kind of forced to do them in a day based on the train schedule, but it's a big day. We also have 300 ties this year, 6 caps, repair replacement of 4 step outs or power stanchions. You can see in the background, you can see that little place that looks like someone could step onto that. That's a step out, and on the north side of the bridge, or Railroad North, Cardinal West end of the bridge, those also carry a big power cable, quite a bit of extra load to get power to that house to move the bridge. 15 stringer repairs or replacements, a bunch of shemming and pile posting, 3 sills, the replacement of the steel end floor beam on the swing span itself. And then the biggest single piece of the scope was 294 bays of longitudinal bracing. So I mentioned before, when you do a cut down, you're required to brace it to stiffen things up. The railroads had a lot of issues with this bridge over the years when it gets hot, even though it's not welded, it's jointed rail, having that rail grow 3,000 feet of rail. Obviously it gets hot and it grows a lot. It's proportional to the length, and having it grow and push things and push these timber bents, which typically will show itself in the fact that it'll pinch the swing span, which is an issue, because if it pinches and they can't open it, then boats can't get through. And even worse, if it pinches when the swing span's open, then they can't get the bridge closed. So the railroad's trying something new this year, putting all this longitudinal bracing in, even on frames and bends that haven't been cut down, to try to stiffen things up. They've tried other things over the years that we've been involved with, like the addition of expansion rails. So just looking at some other work that we did, you can see new bridge ties here underneath the 210. You can see a brand new cap there. Then you can see a concrete precast cap in the background, a couple. They're a little bit shallower, and then so they have a top piece to make up the depth. That's something that was new to us this year, putting the precast caps in. It seems to be a good product, certainly heavier, but the big issue they have, all this stuff is Doug fir with copper naphthenate preservative. The biggest issue they have with the caps is crushing. They'll rot and crush, so that should obviously be helped a lot by the precast.
Who made the precast ones, Ben?
I don't know. All the material that NECR has been buying out their own projects for the most part. Ron, did they have a stamp or a name on the precast?
Yeah, I think it's American Concrete.
Never heard of them.
They're neat though. I mean, they've got all these PVC, I guess it's PVC conduits in them for your pins and bolts, and so no drilling. Unusually high lake levels this year have made all the lower work that requires, cuts below the rot line, or even bracing, where you really want to get nice and low to get a good strength of figure. It's been made it really hard to schedule. From July 10th on, that lake's been up. But we've still got the majority of the work done, over half the contract, quite a bit over half. We got the floor beam done, and we've got a lot of the low work done before the lake started coming up here a couple weeks ago. That floor beam on the swing span was quite a little job. It appears to have been damaged, maybe in previous times when the wedge bearings weren't adjusted right, and the train coming onto that bridge probably put undue stress on it when it hit that floor beam, because it had some pretty good tears where the stringers framed into the back. So we replaced the floor beam web, which required field measuring, lead abatement, rivet removal, stringer shoring, some surgical demolition, and a lot of match drilling, bolting and torquing. One nice thing about a movable bridge is that unlike most end floor beams where you're kind of in a tight spot, is we could just open this and have some
Make it
room to
accessible.
access it. Of course, like any bridge work and railroad work, the time is of the essence with trains coming, but you guys did a good job. You can see someone here running a mag drill with 2 fingers while they're working on the other side of the beam. So that looks like somebody that's done some drilling before. We went over most of this verbiage, but here's another picture of the guys doing some longitudinal bracing. So for now, with water levels back up and most of our work, being down low, cut downs, sills below the rot line, we'll demob for now. But we'll come back when maybe June or July when the lake's back down 96, 95.5, and we'll wrap up the rest. Here's the picture of part of the team. We were running 2 crews. We had like 11, 12 guys up there, in late winter, but here's a few of them. That's it.
Cool picture.
From the archives, Gene Trombley and Dale Fecto installing a miter joint. So part of the automation process was to have these miter rails that, the train can run on. But then, of course, when you move it, they've got to retract back out. So you can see the linkage. They're moved by these linear actuators. Everything's limit switch controlled. It's pretty neat. If you have a chance, check out that YouTube video. That was a pretty cool project.
Gives you a sense of the precision needed for the bridge to go right into its correct location at the end of these long stretches of kind of a floating bridge, right?
Yeah,
And
it's super flexible. You got this thing that needs to be pretty dialed to work, and it's connected to thousands of feet of relatively sloppy, flexible construction.
Like a
Think you-
roller coaster. No
If
kidding.
they were to do it again, they would put the center pier would be the same, but they would have rigid,
Oh, the ends.
abutments at each end of the swing span that are pile supported and aren't going to move, but they don't have that at all. So I think and Ron and Ben, you probably know the exact measurements, but I think at the expansion joints, I think there's a pair. So 2 pair, and each pair can travel like up to 30 inches. Is that correct?
The expansion rails. Yeah, Ron, you'd know that.
Yeah, yep,
Holy cow.
that's right, Ken.
30
So
inches.
that just gives you a sense of how much movement can happen from the thermal expansion and contraction.
That trestle's like 100 years old, you guys, right? Something like that.
110, 100.
Yeah,
Yeah.
I think it was right around the 100-year anniversary when we automated it.
So they
Which
ran
is-
steam trains across that baby back in the old days.
That's a good point.
That's cool.
Yeah.
That'd be cool to find an old picture of a steam train locomotive going across there.
There probably are some out there. Check with Jim Murphy, right?
Yeah.
Yeah.
Murphy, Hugh.
I
Yeah,
have a
Hugh.
quick story about rails. We did a jack and bore up in Barton, and we ended up having to open cut it. We had to take the rail apart first thing in the morning and tried to put them back at the end of the day right before dark, and we couldn't get them back together.
You didn't have Ron Wall in
Very
there.
happy with us.
Yeah, you should have Ron.
And that's jointed, and that's not even welded rail.
Wow.
Mhm.
Whoops.
So, pretty cool stuff. Thanks a lot, Ben and Ron, and we'll pass it back to Matt and safety team to close out the meeting.
Yeah, thanks, guys. Really good photos. If you're watching in a group setting, please send over attendance so we can capture today who participated in it. And we will be launching the YouTube video here shortly. Let's have a safe day. Let's have a great day.
Okay, take care.
Guys.